Hello folks, and welcome to installment number 39 of the MLOs for Math 2201. Today we're jumping into the statistical reasoning unit, which is Unit 6, or Chapter 5 in your textbook. I think it's probably going to be about the third one you do in the course, so isn't that funny? 6th unit, 5th chapter, third one you do. Weird. So we're going to talk about the first topic we want to see here, which deals with sections 5.1 and 5.3 kind of together, called dispersion. And dispersion kind of starts us off from a way back when you were in grade 9 and talks about a new idea about statistics. Now in grade 9 you learned about something called, you learned about measures of what we call central tendency. So you had mean, you had median, and you had mode. And each one of those was a way to sort of take a data set or a whole bunch of numbers that were related and sort of find the center of it. So that's what we call it, central tendency. So they're all sort of different forms of average. Typically when we say average, we mean the mean though. So you should remember what all those things are, and you're going to hear this word a lot in this unit. So we will talk about the mean. So let's remember, let's start off by saying we're going to look first of all at the idea of dispersion. We're going to define range as one way to measure dispersion. We're going to define something called standard deviation as another measure. And then we're going to apply some standard deviation to solving some problems. So we won't get into too much of that in this session. Okay, so first of all, what is dispersion about? Well, you already know about how to find the center of a data set or an average or a typical value using mean, median, or mode. So first thing we want to do with these is we want to compare the mean of each data set. So we might say that an average or a mean value would be somewhere in the middle of this group or somewhere in the middle of this group. So these are just, they're actually something called histograms, which we're going to get into later. But they're very similar to bar graphs, which you've seen before. So it's not a big stretch for you. So somewhere in the middle there, you're going to have that mean value. But then we also talk about not just where the center of the data is, but how much or the degree to which the data are spread out. So you can see in this first group that we range from a lot farther left and a lot farther right, and the data are kind of spread out a little more than they are in this central group where everything is kind of clustered around the middle. It's still a little bit of spread on this one, like it's spread out a little bit, but not nearly as much as we are in the first group. So we would say that the first group has a higher dispersion than the second group, and that's the statistical term for it. It's dispersion. So we have two things that we look at to analyze data so far. We have central tendency and we have dispersion. Now for central tendency, you had three different ways to measure that: mean, median, and mode. For dispersion, we measure that two different ways. Well, there's three, but there's only two that we're going to look at here really. So the first one is called the range, and it's a real simple one to do. The range is just the difference between the maximum and the minimum values in a data set. So let's look at these two data sets that we have here. So each of these data sets represents like a small class, and those are the grades that a particular group of students had on a test or an assignment or something. Okay, so if we look at the two data sets, we could calculate the mean or the median or the average or the mode, and that would tell us sort of where they're all centered around, but we want to know the degree to which they're kind of spread out. So we're going to use this thing called the range. So over here in the first data set, I think the smallest value, ouch, somebody didn't do so well, had a 48, and I think the biggest value that we see there is a 95. So range is a real easy thing to calculate. All we have to do is take that 95, subtract the 48, okay? And that gives us a 47. So this data set has a range of 47. So from the smallest to the largest, it's spread across 47 units. For the other set, I think the biggest value I see here is an 80, and the smallest value is a 70. So my range for this one is just going to be 80 subtract 70, which is just 10 units. Now, it's quite possible that these two sets of data for these two classes might have an average that's really close together. They might both be somewhere around 75. But that doesn't necessarily mean that's the whole story for the data. The whole story is much different. We have to look at not just where the center is, but how spread out they are. So range is one way for us to measure dispersion. There is another way, and it's called standard deviation. So standard deviation doesn't just account for the smallest and the biggest value. Standard deviation kind of gets you an average of how spread out things are for every data value. So one way to think about it is to think that standard deviation is sort of the average distance that every single, if you count for all of your different data values, the average distance they are away from the mean, more or less. It's actually the square root of the average square distance, but whatever, just think of it as an average distance, and then we'll quickly learn how to calculate that for a small sample value like we have here. So let's say we have this set of data, and it's got all these numbers in it. So the first thing we can do is we can calculate the average of them, add them all together and divide by, I think there's 6 of them. So we get a mean of 73.2. Okay, so what standard deviation says to do is find out how far each data value is away from the mean. So basically we subtract the mean from every single data value. We call all the data values x's. So we get these 6 numbers. Okay, after we have those 6 numbers, then what we do is we square them all. So we go through that process. So what we have is x bar represents the mean. This little thing up top we call a bar. So x bar, and then we take x minus x bar for all the values, and then we square all those. And then when we're all done squaring them all, we add all those squared distances together. Okay, strange enough. So what that is it's sort of the sum of all the squared distances. And then we divide that by the number of data values we had. So we take that number up top, we divide it by the number of data values that we had, just like the formula says over here. And then we take the square root of the answer. So it says 14.6 is the standard deviation. So what that means is that on average, a typical data value here might be about 14.6 units away from the mean. Okay, so it's an average squared distance away from the mean, square rooted. We just usually think of it as an average distance away from the mean. So dispersion refers to the degree to which a data set is spread out. And the simplest measure is range, but it doesn't tell us a whole lot, just the top and the bottom. There might be outliers or something. So a more complicated, yet a more telling measure of dispersion is called standard deviation. And it more effectively measures the distance the data values are away from the mean. Okay, so we'll do a little more practice with calculating standard deviation, etc. in the next video. Thanks.